Hey everyone, thank you for being here. Welcome to the Sustainable Blockchain Summit EU, where we are. Our goal with the summit is to bring together the people in the world who are the most knowledgeable about sustainability and about Web3, right? So the intersection of sustainability with Web3 to build tools to decarbonize the global economy faster than is possible without Web3, right? With just Web2 tools. So I want to welcome you all here. Thank you for coming. Please help us decarbonize the summit. So one thing, let's see, is this on? One thing you can do, there's a QR code around here. You might have seen it on the door. It's going to be on a slide here. You can also go to tinyurl.com/sbs-emissions. Please let us know how you got here. Please let us know your transportation. We want to do a comprehensive carbon accounting of the emissions that it took to actually get everyone here, and connect that with offsets. And in a minute, oh yeah, it's here. There's a QR code. Perfect. That I'm probably blocking. But please let us know this information. We will do that accounting and match transportation emissions with Web3 native offsets. And so what I wanted to start out with is this idea that couching global warming in terms of warming since pre-industrial times makes this seem slow and gradual, but it's not. So here's a graph of average global temperatures over the last few decades. I was born in 1988. About 2/3 of warming has actually occurred during my lifetime, right? So this work should feel very urgent, right? We have, over the course of a few decades, gone from a regime that's not just the temperature in which we built our industrialized society, but also most of human history and prehistory. We've moved from that regime into this completely unknown, much warmer regime. You saw this over the past week. Here's a map of heat waves that hit all across Europe and a lot of the rest of the world. We registered some of the highest temperatures ever recorded in weather stations across the EU just earlier this week, right? Again, this should feel very urgent. And to underscore this point, climate change isn't even the planetary boundary that we should feel the most threatened by, right? So the planetary boundaries framework gives us 8 different categories of variables that we can measure about the natural world and defines safe ranges for those variables. We're exceeding the safe range for global warming, but we're far, far out of the safe range for biosphere integrity. So this is the rate of extinction of species. We're just like fundamentally in an unstable regime, an unsustainable regime for the global biosphere, and also phosphorus and nitrogen flows. So that's things connected to agriculture, right? So we need to broaden the scope of what we think of as the Web3 sustainability movement to really include all of these variables, with carbon getting a huge amount of the emphasis, and rightly so. It's very important, but we need to broaden our scope as much as possible. And so what I'm going to be talking about today, firstly, is this thesis that Web 2 plus fiat money is actually insufficient to solve these problems. I'm going to talk about the philosophy of that a bit. I'm going to talk a little bit about what we're doing in Filecoin. My name is Alan Ransil. I'm the team lead for Filecoin Green, which is the sustainability initiative in Filecoin. Talk about how we're building these systems as sort of an example of something approaching a global Web3 native carbon accounting ledger. Talk some about what the generalization of that looks like. What does the Web3 global sustainability ledger look like? Talk a little bit about why net zero is not enough. And then challenge everyone to the fifth number 1 on this list. Challenge everyone to think about a few different things at the summit. So the economy is an information processing system, right? So you can frame the difference between Marx and Hayek as fundamentally, where does the information reside in the economy in order to make the decisions that we need to make, right? Another place you see the economy as an information processing system is in Coase's theory of the firm. So Kos asked, why do companies exist, right? Why don't we just have an economy in which individuals exchange with other individuals and there's no firm type, no company type structure? And the conclusion he came to is that the boundary of a firm has to do with trust, right? So the difference between transactions in between firms, external transactions, versus transactions internal to firms is this presumption of trust and presumption of alignment that changes which types of transactions you can make. So within a firm, you have these sort of less bounded, more broadly scoped in time as well as in complexity transactions that you can only bring this sort of complex, rich information into these transactions because of that assumption of alignment within firms. Whereas external to firms, you have much simpler transactions that often take place over much narrower periods of time because all you can do is exchange price signal information efficiently. You can't exchange that rich information because you don't have a way of verifying it. You don't have a presumption of alignment from firm to firm, right? And so what that means is that the centralization that is inherent to companies that we've built our entire extractive economy based on, that centralization within individual firms is an informational crutch, right? So only price signal information can pass in between firms. We've built our extractive economy using this crutch. This presumption is really central to how we've built the economy. And now we have the tools to rebuild it, right? So what does this mean for something like the greenhouse gas protocol, where we really need much richer informational sets than just price signal information to be able to be transported in between firms? So, there's people with a wide range of backgrounds here. I'm going to sketch out the greenhouse gas protocol in sort of very broad terms quickly. So you want to understand what the emissions are for an individual company or an individual organization, an individual project. You look at the scope 1 emissions. Fire is all sorts of cool colors here. You look at the scope 1 emissions, which are the burning of fuel. You look at scope 2 emissions, which are shadow electricity here, the emissions due to use of electricity. You look at scope 3 emissions, which are emissions due to the supply chain of this company or this organization or this project, right? So scope 3 emissions, by far the most complicated analysis that you have to do within the GHGP. And then what you want to do first is do everything you can to reduce your emissions within this project or this company due to scope 1 through 3. Then what you can't reduce, you want to mitigate using things like offsets. And then once you've done that, you have this accounting ledger. You know what your carbon intensity is. You can use that in your internal reports and your reports to investors. You can also pass that information downstream to your customers so they know what the carbon intensity of your products is, right? So emissions accounting is a complex exercise, and building up, right, to why do we need Web3 in order to track emissions across the economy. So emissions accounting is a complex exercise, and so it takes auditors months to complete. And if you imagine a value chain, possibly a very complex value chain, and every individual link in this value chain is only doing this exercise every year or so, because it takes auditors manually a long time in order to do this, every hop down this value chain, the information becomes a year old, right? And so if company A changes something, they report after several months, maybe a year. Company B gets that information. It ingests the carbon intensity of the products from company A. Then it takes another year in order to do its own sustainability reporting. Then it passes that information to company C. That information is 2 years old by the time it gets to company C. So if you see the economy as an information processing system, then you see the time scale of information flow as being 1 year per hop. And then you look at the IPCC report, which says we need to decarbonize the entire global economy by 40% within 8 years. This is just not going to work, right? So that's why we need to build better tools, right? The entire global carbon accounting system is held up by Excel, and we need to fix that. So the second number one, building sustainability tools into the Filecoin ecosystem. How are we approaching this? So Filecoin Green is our effort to turn environmental accounting into a Web3 superpower. So we want to do this by making Filecoin verifiably sustainable and by building the best tools in the world to reduce and to measure and reduce environmental impacts with all of you. IPFS and Filecoin. IPFS is a content delivery network. Filecoin is the data storage layer of Web3. This is a lot like in the Web2 world, Akamai versus something like AWS or Google. So Filecoin uses electricity in two different ways. You have to seal data. So sealing is the process of setting up a zero-knowledge proof circuit that's going to allow you to prove that you're storing data over time. Then you actually have to store that data. So these are two different ways Filecoin uses energy. We can take proofs of sealing and storage from the Filecoin blockchain, translate those into energy use profiles. These slides, by the way, are at tinyurl.com/ransil-sbs-paris. If you want more information, links to a bunch of the information in these slides. We can translate the sealing and storage proofs on the Filecoin blockchain into an energy use profile so that we can look at, for the network as a whole and for individual nodes on the network, we can estimate their energy use. And we have a dashboard in order to do that. One of the sets of questions that you can look at then is, how big is the Filecoin network? How much energy does it use? It's about 0.87% of all of the data stored in data centers throughout the world at the moment, and uses about 0.67% of the energy used by data centers. That means that sealing energy is about comparable, little less, than typical workloads run on data at data centers, right? So that's a snapshot of sort of the energy intensity of Filecoin at a large scale. But the other thing that we can do is look in detail at what the energy used by individual nodes is, right? Again, rooted by the proofs in the Filecoin blockchain of how much data they're onboarding onto the network and storing, translate those into energy use profiles. We can look at the locations of those nodes and get an idea of how this network is interacting with local power grids. Right, with this verifiability, because you're tracing it back to these cryptographic proofs of storage. And so then we can take those nodes and we can connect them to renewable energy through traditional renewable energy markets. So the way this works is that, say you have a solar farm that's connected to a power grid that a Filecoin node is connected to. They can put energy into that power grid. They can then mint a renewable energy certificate, which the Filecoin node can purchase, and then we can make these claims about using renewable energy. So that purchase is a public proof that this node uses the renewable energy produced not just in general within a region, but from a specific solar farm or wind farm over a given time period, right? So that's the degree of verifiability, the degree of granularity that we're aiming for in these systems. So we can take these energy use profiles from the Filecoin Energy dashboard and match them with RECs in order to make these claims. And we've purchased about 1.618 terawatt hours so far of renewable energy for the networks, which is a tremendous amount of renewable energy. And so another thing that we're doing is trying to support storage providers in becoming more verifiably sustainable. And so you can go to filecoin-green.gitbook.io to learn more about this. There are 3 different sustainability tiers based on the rigor and transparency of these sustainability claims. And we've taken the information in this, and Holon, which is a Filecoin storage provider, has published an ESG report both for their operations and for the Filecoin network as a whole, which we believe is the first comprehensive ESG report for a major crypto network that we just announced today. So please check out the report and check out the press release that's out there. So when I talk about different tiers of sustainability, right? Like what are we shooting for? What would we really like people to be able to do with sustainability data and mapping that to consumption and ultimately to services? So this is the roof of Descent, their storage provider in Amsterdam. They recently put solar cells on their roof, and they hooked up both the solar inverters and PDUs measuring the energy use of their IT infrastructure to this extensible dashboard, which allows us to scrape that data, make it publicly available, and then you can then see the PDU measurements of server racks running all of these operations, so running their set of Filecoin miner IDs. You can then see the net energy use. So this is just a readout from their net draw from the local power grid. And you can see hour by hour or 15-minute period by 15-minute period what their rooftop solar production is, right? So this is again, like, this is the level of granularity that we're aiming for, and the level of verifiability that we're aiming for, right? So they're submitting all of this information to a third-party auditor. That third-party auditor is signing it and making it available on IPLD, where everything is being content addressed, everything is being unambiguously mapped to these services, right? Which is the baseline that we're going to build all of this Web3 native sustainability accounting based on. So third, number one, what will the Web3 global sustainability ledger look like? Well, so we've gotten part of the way there, right, in talking through this. Here's the Filecoin value chain. What we're doing is building tools to measure the environmental impact at every spot along this value chain, which then means that anyone, no matter where they are in the value chain, can see what decisions they're making and how they can make decisions to reduce their environmental impact, right? What is the environmental impact of the decisions I'm making now? What options do I have available to reduce that impact? And so I'm gonna come back, right, to this claim that fiat money is a computationally insufficient substrate for modeling environmental externalities, right? This is fundamentally why we need Web3. What does that mean? So fiat money, it knows how to add, right? It knows how to add and subtract. Like you have some money and you have some other money and you put them together and you have the sum of that amount of money, right? But that is not how ecosystems work, right? So you have a plot of land and you have another plot of land, and the question is, when I have those two plots of land and I put them together, what is the effect on things like biodiversity of those two plots of land, right? And you can't just tell from the value of those plots of land, right, what the effect of biodiversity is going to be, right? So I have, this plot of land costs this much money, this plot of land costs this much money. So, are they contiguous? What is the sort of native biodiversity of that land? What are, local phosphorus or nitrogen flows that might degrade biodiversity? All these different things. You just can't reduce environmental value to a price signal, right? You need these richer data sets to flow through the economy, and you can't wait a year for every hop from company to company for that information to flow. So we need better tools for verifying that information as it flows through the economy, so auditors don't become this bottleneck, right? So back to the greenhouse gas protocol. Centralization is an informational crutch, right? So the way we do this now, again, is by auditing all of this information for company A, auditing all this information for company B, and every time we want to do a report, we have to go through that entire auditing process, right? So we need to pass information that's richer than just price signals from firm to firm. And so we can rebuild this architecture, right? We can rebuild this architecture using primitives of Web3. We can rebuild it using things like content addressing, right? So content addressing allows us to refer to data based on the content of that data rather than the location of that data on the network, which means we can make claims and unambiguously cite the information that is leading to those claims, right? We can make data self-sovereign, so when it changes, we know who made that change, just like fundamentally, we know who made that change. We can build public verifiability into these claims. These are things like I was talking about using Filecoin proofs of sealing and storage to underlie these energy use profiles, right? So you can publicly verify those energy use ranges based on cryptographic information on the blockchain, right? And we can use zero knowledge, which is I don't have a huge amount of time to get into here, but fundamentally, you want to allow company A, say, to make representations to everyone they do business with and be able to prove that what they're telling one of their customers or one of their suppliers matches what they're telling everyone else they do business with, right? But they don't want to reveal their entire book, right? They don't want to tell everyone exactly what their carbon intensity is due to every single thing on their balance sheet, right? So we need to build, and we have the ability to do this, right? Filecoin is the largest application of zero knowledge proofs that's in production right now. We need the ability to allow people to make these claims and prove these claims, right? Prove that what they're telling one person agrees with what they're telling everyone else without actually exposing all of the underlying data, because they're never going to agree to that, right? So we actually have the cryptographic tools to rebuild this informational architecture to allow this information to flow quickly from point to point in that supply chain. And that's what we need to do. So we have our work cut out for us. And once we do that, the goal then is, can we allow this information to flow through the economy at the speed of price signals, right? At the speed that price signals flow through the economy now, can we allow sustainability information to flow from point to point? So we can rebuild the global accounting system, right, to transmit data in minutes, not in months, right? To transmit sustainability data, to transmit carbon accounting information in minutes, not in months. So I wanted to touch briefly on why net zero is not enough, right? So I took this this from the title of a book by Holly Jean Buck, who's a professor at the University of Buffalo. Net zero is not enough because if we focus on net zero, we ignore the fact that a world in which we're net zero because we emit as much as we do now and then remove that amount of carbon from the atmosphere, that looks very different from a world in which we are net zero because we emit drastically less than we do now, right? And this is what you should think of in order to make that point clear, right? When you are buying fossil fuels, you are locking in this extractive infrastructure that is causing damage beyond just that number, right? That CO2 emissions intensity number. And so we need to, this is the reason for not building all of these systems using an architecture in which we just look at overall emissions for a project or a network or whatever it is and match that with offsets, right? Offsets are really important, right? They are part of the greenhouse gas protocol, but the way you get to net zero is first reducing all of your emissions as much as you possibly can, so you are locking in fossil fuel infrastructure as little as you possibly can afford to. And then you offset what you can't reduce, right? And because every time you are paying for fuel, you are locking in this type of stuff. And that is degrading ecosystems. It is making us surpass planetary boundaries in a really detrimental way, far more than just by emitting CO2, right? So net zero is important, but net zero is fundamentally not enough. And so in the last few minutes, I had a few challenges for us all to think about at the summit. And they are 1 through 6, labeled 1 through 6. So that's kind of magical. So the first thing is, can we reduce both the magnitude and the net value of emissions, right? So that means we don't just look at that top line number. Can we build systems that take this rich data on all of our environmental impacts, all of the ways in which we are contributing to planetary boundaries, and preserve that information and allow anyone anywhere in supply chains or value chains to see what those impacts are and what they can do to reduce those impacts? Secondly, can we expand our notion of environmental goods beyond climate change? Again, planetary boundaries. Third, can we empower people on the ground? So Web3 has this tremendous power to involve people on the ground directly in all of these decisions and in all of this governance. We lose, so there's not only transparency, right? Transparency is important, and frequently when you have when you go through a lot of intermediates, right, you lose some of that transparency, but you also lose knowledge, right? People on the ground know more and are more directly affected by all of these decisions, right? And so we need to build systems that empower the people who are actually involved in these ecosystems, right, and are directly affected by facts on the ground to be fundamentally part of the governance of all of these systems. Can we hold sustainability claims to the same standard of verifiability as account balances, right? So Bitcoin, right, one of the major innovations of Bitcoin was, well, wouldn't it be great if everyone's banking information were public, right? Right. And so, it's pseudonymous, but you can see everything, right? So that is the standard that we should hold ourselves to when we are building these accounting systems, right? So how can we do that? Then fifth, think about what Web3 sustainability tools are fundamentally impossible with Web2, Right. So I think that's a frame that is sometimes assumed, right, or sometimes lost. But can we think really, really deeply about like what are we doing here that is actually impossible to do with just fiat money and Web 2? Because my hunch is that's how we're going to make the most progress on these problems. It's going to focus us. And then can we practice Rawlsian tech development? So Rawls was a political theorist from the 20th century, and he said that when you are designing a social system, can you have the people working out the rules for that system be under a veil of ignorance? Which he meant that they don't know which position in that society that they're building they're going to occupy. So can we build tools that lead to a world that you would be happy to live in, not knowing where in that world you're going to inhabit, right? Can we look at things from this lens of doing the most good for the people who are least advantaged in that society, so you would want to live there no matter who you are in that society? And so I wanted to really deeply thank a ton of people and organizations that are involved in this. The United Nations Framework Convention on Climate Change, Alex Paris is going to be talking soon. The Filecoin Foundation, the Outercore events team has done an amazing job at putting all of this together. Gitcoin, Chainlink, Hedera, and Fluence all sponsored the hackathon that we put together that you're going to hear more about in just a couple of minutes. And please, this is the Filecoin Green team. All of the work I've just been talking about is the work of these people who are all specifically there, but are going to be around over the next couple of days. So please, find us, meet up with us, talk with us about this work. And then here are different ways to get involved. You can check out the tools at filecoin-green.gitbook.io. You can look at the sustainability guidance. If you are, if you're interested, there's a bunch of different ways you can plug in. Again, these slides I just went through are at tinyurl.com/sbs-emissions. And please, again, help us decarbonize the summit by telling us how you got here so that we can go through a process of matching that transparently with carbon offsets in order to reduce our impact. So thank you so much for being here, and I'm really excited for the next couple of days.